Hey everyone, my name is Waqqas Sheikh, and I'm a software engineer at TribalScale. So we're going to talk about Go, your next backend language. Before we begin, has anyone here heard of Go? Oh, really good. And has anyone used it in production or? That's pretty good. Okay, so Go was first announced in 2009, and the version 1 was released in 2012. And ever since then, its popularity has been on the rise, especially in the last few years. Stack Overflow conducted a survey in 2018, and it was voted as the 5th most loved language of the year. And 16% of the survey takers said that they would like to learn Go as their next programming language. So that's more than Kotlin, Java, and even Swift. Its popularity is all over the world. You can see it in the States, South America, Russia, Asia. There's a bit of a gap in Africa and the Middle East. Hopefully we can change that. And some of the biggest companies in the world are all using Go for a big part of their operations. So you have companies like Uber, Dropbox, Docker, even SpaceX. Over here in Dubai, I know that Namshi is using Go. It seems like there are a lot more people. So, what makes Go so cool? When you come right down to it, there are 4 main reasons. Number 1, scalable concurrency. So Go introduces a new concept called Go routines, which are like really lightweight threads, and they make concurrency really efficient. One of the main problems that we have when you work with threads is sharing memory between 2 threads, and Go avoids that altogether. Instead of sharing memory between 2 threads, you pass data along 2 threads. And it's a Go proverb called "Do not communicate by sharing memory, share memory by communicating." Second thing, ease of deployment. When you build your Go code, all your source code and all of its libraries are combined into a single binary that's ready to go. You can just deploy it to your container. And not only that, Go's compiler supports cross-compilation, so you can work on your Mac OS, but still compile for a Linux container. Thirdly, Go is feature light. It doesn't have a whole bunch of flashy features. It's very minimal. You can learn it very quickly and get up and running. And lastly, performance. Go has really fast compilation. The entire source code of Go compiles in 19 seconds. And Go's own performance is pretty good compared to other interpreted languages, although it's a bit medium compared to some other languages, but we'll talk a bit more about that. So that's why Go's becoming pretty popular, and a lot of big companies are using it. So today what we're going to talk about is the history of Go, what was the need for another programming language, what are the key features about Go, what are its limitations in case you decide to use it, and how you can get started with Go. Good? Okay. So the goals of this talk are to get you interested in Go, get you to try writing Go yourself, and maybe consider Go for your next project. Right. So, the history. So Go was developed by these 3 gentlemen. Ken Thompson, you probably heard of. He developed C and Unix. Rob Pike is the main developer of Go. He also developed UTF-8, which is how you send emojis to each other, and also Clang operating system. And then you have Robert Riesemer or something, who develops distributed systems in Google. So these are people who work on a really large-scale platforms. Okay. Now, why does Go exist? So what happened in 2009 was C++11 was announced, and this C++, which is already a huge language, added even more features. And this was a problem for Google, because they relied on C++, but it was increasingly becoming more difficult to find C++ developers. And during that discussion, what they realized was that for programming languages like C++, you get very high performance, right? But the languages are really complex, and they tend to be a bit verbose. On the other hand, scripting languages, they're good with young developers because they have low complexity, they have low verbosity, but their performance isn't all that great. And then you have the enterprise languages. They're very verbose, they can be a bit complex, but the performance is not, it's just medium. So what they wanted to do was to create a language that tried to do well in all three areas, like high performance, low verbosity, and low complexity. Okay? So the goals of Go were the following. Number one, it should be a static type language. The lack of a type system is seen as a failure in languages like, not really a failure, but a limitation in languages like JavaScript or Python. Second, it had to be readable and minimal boilerplate code. So it shouldn't be like an enterprise language where, like Java or C#, where you have a whole bunch of boilerplate code just to do routine tasks. Thirdly, it had to be scalable. So enterprise languages, again, they tend to use a whole bunch of resources while they're operating, which doesn't really scale well. So Go had to be a language sort of like C. It's lightweight, but it can work really well. It has good performance. And lastly, it has to be designed for multiprocessing. Because in 2009, you had multi-core processors, but you didn't have languages that were taking advantage of them. So these were the goals for Go. And before we continue, I just want to say, we looked at this chart earlier. So where does Go actually fit in all of this? So Go accomplishes low complexity, and it tries to have low verbosity, but at the moment it's kind of verbose. And its performance is, it's slower than C or C++, it's faster than scripting languages. It kind of just skirts around Java or C#, but it's a pretty good choice in terms of performance as well. So now we'll actually look at some Go code, starting with Hello World, of course. So this is a Go program. So this is the starting point of any Go program is the main package and the main function in that package. All right. What we're doing here is we're simply printing Hello World. We import the func package, that's its actual name, and we're importing a function called println, and we're just printing Hello World. How do you run Go? It's really simple. Go run, and if this file is called main.go, you just do go run main.go. Okay. So let's actually do that. I'm going to clear this, and here I have a whole bunch of files. I'm going to go run hello.go. Okay, Hello World. Is that easy to see?
Can we get bigger?
Yeah. Go run hello.go. Yeah. Okay. Hopefully this is better. Okay. Now. So now we're going to look at some of the key features of the language. But before we do, most people, when they first come across Go, find the syntax really, really weird. So I think it's good to spend a few minutes just to go over the syntax, and then we're going to look at the main features of Go. That's its concurrency, its networking, its garbage collection, and its tooling. Okay. So the syntax. How do you declare a variable in Go? It's pretty simple. You use the word var, the name of the variable, the type. Notice that the type comes after the name, and then you assign a value. However, Go does have type inference, so you don't need to mention the type if it can be inferred. And then this var is pretty much useless. So for that, Go has the dot colon operator, which declares a variable and assigns a value all in one go. Okay? Exported and non-exported symbols. So the case system is a bit weird in Go. If anything starts with a lowercase letter, it's private. You can only use it within the same package, or what they call non-exported. And anything that starts with the uppercase letter is exported or public. So we have two packages over here: package foo, package main. In package foo, we have a private field called hello world with a lowercase h, and a public function print hello world with an uppercase. So in the main package, we can use the print hello world function because it's public. We can use this hello constant over here because it's private and it's in the same package. But we can't use this constant over here, hello world, because it's a lowercase letter. It's private to the package foo, and it can't be used outside that package. Okay? Sorry, we just have to go this. I know it's a bit boring, but we have to go through this. Next thing, for loops. So Go only has one kind of loop, which is the for loop. The reason is all other kinds of loop can be written as a for loop. This is what a for loop looks like. It's pretty much the same as any other language. You're creating a counter until 10, and you're simply printing the numbers from 1 to 10 if they're odd. I think I missed something. Oh yeah, here. If statements. So if statements are the same in Go as any other language, there are two differences. Number one, you don't need the parentheses. And number two, in Go you can declare a variable inside an if statement the same way as you can declare a variable inside a for statement. So if you've written a for statement before, you know that you usually declare a counter, something like int I is equal to 0. You can do the same thing in Go. So if you look at the if statement that we have over here, it has two parts, one part in yellow, one part in green. In the yellow part, we're declaring or assigning a variable with the boolean is age greater than driving age, and then in the green part, we're actually using that variable. So we have a variable that's local to an if statement, and this is we already spoke about the for loop. You'll notice that I'm using that if statement syntax over here, and next thing is array slices and for range. So Go has a few built-in containers, including arrays, slices, and maps. We'll look at maps in the next slide. Arrays are fixed-size storage, right? So they can't grow any bigger, and they can't grow any small. They can't shrink. How do you declare an array? It's square brackets, the size of the array with its type. So in this case, we're declaring an array of 5 strings. There are two ways of doing it: the declaration, and then just using a literal syntax, which is on the second line. Slices are sort of like array lists. They grow and shrink as you add or remove items. The syntax for that is the same as arrays, only you don't need to specify the type. And then you have the for range loop, which you can use to iterate over containers. How does the for range loop work? You basically, so over here we have a slice of numbers from 1 to 10. We range over these numbers, and for each item we get its index and its number. And over here what we're doing is simply printing the index plus 1 is the number. So if we run this code, we'll get, what is it the numbers from 1 to 10. All good? Okay. And I think we're almost done. Maps. So maps, pretty straightforward. Key value storage. To declare a map in Go, you use the map keyword followed by square brackets. What's inside the square brackets is the key. What's outside the square brackets is the value. So here we're creating a map of countries and their country codes. How do you get a value from a map? It's the same as any other language. You use the square brackets operator. So we're getting the code for the country Kuwait. And you'll notice that when you get a value from a map, you don't get one value, you get two values. The first one is the actual key value, and the second value is a boolean specifying whether the value was found or not. I know that sounds confusing, but you get used to it. So in this case, we have a found boolean. We're checking if it's true, and if it is true, then we're using the code that we got from the map. Does that make sense? Okay, good, thank God. And then you'll notice by now that Go supports multiple returns. So a function doesn't have to return one value, it can return any number of values, all right? And it's handled at the assembly level, so there's no object, there's no tuple. The assembly code actually returns multiple values. And you can see how that works following this link. And this is how Go's way of returning a value or an error, like we saw in maps. Okay? So that's the basic syntax stuff. So now we'll get into something that's interesting, which is starting with concurrency and Go routines. Okay, Go routines. So Go routines are functions that run concurrently with other functions. Now this is an important point. They are not the same as threads, right? You can think of them as mini threads, right? Very, very, very mini threads. So what's the difference between threads and Go routines? Well, first of all, Go routines are cheap. It only costs 2 kilobytes on the stack to create a Go routine. So you can create thousands of them and it'll be okay. And whereas a Java thread costs 1 MB, there's a lot of like boilerplate and context that comes with the thread. Okay. Second thing is that they're lightweight. So the way that Go routines work is that a single Go routine, multiple Go routines are all combined into one thread. So this is really scalable. So if you think about Java, right, it creates a thread for every single request that it receives. So if you get a whole bunch of requests, you can eventually run out of errors. And the way Java fixes this problem is it uses thread pooling, right? So you reuse the threads that are not busy. But in Go, since you can have thousands of Go routines inside a single thread, you can really like you can get a lot done using only a few threads. Does that make sense? Right? Thirdly, non-blocking. So people from Node.js will appreciate this. If any of the Go routines block, what Go will do is it will move all the other Go routines that aren't blocked into a separate thread so that only that thread is blocked. And this happens automatically. You don't need to worry about it. So just like Node.js, Go is non-blocking. And finally, parallel execution. If your like processor has multiple cores, Go will take advantage of them. Okay? So what's the syntax like? It's really, really, really easy. How do you start a Go routine? You simply call the function with the word Go in front. That's it. That's all you have to do. So here we have two functions, numbers and alphabets. Numbers prints numbers and alphabets prints alphabets. And we want to run these two functions at the same time. How do we do it? We simply call the functions and put the word Go in front of it. That's it. So if we run this, we'll see letters and numbers just follow one after another. So look down there and yeah, a whole bunch of numbers. So we only ran this code for 3 seconds, so yeah. But you can do more exciting stuff. Let's say you want to communicate. Let's say you call a function in a separate thread, but now you want to communicate it. So for example, you want to load weather data from an API, and once the request completes, you want to get the data back from the Go routine. How do you do that? Well, Go provides another feature to do this called channels. Channels are a way to send messages to a Go routine and to get data back. And using a channel is only 4 steps. Step number 1, creating a channel. That's the syntax over here. Make chan is a special keyword to create channel, and channels can send messages of only one type. So in this case, we're creating a channel that sends strings. All right. Second step is we pass the channel to the Go routine that you want to communicate with. So here we create a function called load weather, which will load weather from an API. Once it's done, we need to provide the function a way to communicate back to your calling function. And the way we do that is we pass the channel to that function. Is that clear? Good. And then to send a message, it's really simple. We use the left pointing arrow, all right? Now the arrow always points left. If it's pointing towards the channel, that means you're sending the message to the channel. So here we're sending a message. It's going to be a bright sunny day, and we're passing it to the channel. And back in your calling function, you simply wait for the message to be received from the channel. And notice the arrow always points left. If it's pointing from the channel, that means you're waiting for something to come from the channel. So we have sort of like a real-world example. We have this load weather function. It loads weather from Open Weather App API. We're just getting the response, reading the body, and sending the body to this channel. Where did this channel come from? We created the channel over here. We're saying that we want a message of type string. We run the load weather function in one Go routine, and in the meantime, we count how many milliseconds it took. We run these two codes together, and we wait for the weather channel to send its data back, and then we print it. So what does this look like if you run it? It should be. Oh, it's not. Okay. Go run. I think it's called weather. Ah, okay. I got it. So 389 seconds later, we get the response from the weather API. So one Go routine was responsible for finding out how long it takes, and the other Go routine was, in the meantime, the other Go routine was conducting the API request. Okay? Now, you can also get Go to wait for multiple Go routines at the same time, and that's done using the select statement. So over here, we have two channels, channel 1 and channel 2. Each channel will send a different message, message 1 and message 2. And the syntax is exactly the same as switch cases, right? Go will pause until either of those two channels sends a message, right? So we have a small example over here. We're creating two channels, output 1 and output 2, right? And then we have two functions, server 1 and server 2, which pretend to make an API request, but really they just sleep for a few seconds, all right? And then we create two variables, S1 and S2, to actually hold the result that we get. And then we use a for loop. Now the reason we use a for loop is that the select statement will only wait for one of those channels to send a message, right? But we wanted to wait for two channels. And the way you do this is you use an infinite for loop, which just keeps going and going and going until you break it. And so what we're doing here is we're waiting for an output from channel number one, output one, and if both strings are set, we break. Otherwise, we continue. In that case, you get a message from channel number two, and then we check if both strings are set, and then we break. Is that clear? Or okay. Now, if you're interested in looking at a more real-world example, this is it. It actually gets what this does is that it gets details about a movie and its trailer from the movie TMDB API, and this will show you how to actually request timeouts, how to handle errors, also how to wait for in-flight requests until they're all done, and also how to parse JSONs. So if you're interested in a more real-world example, you also have a link to that included. One thing I'd like to show you while we're here, it's just a cool little feature. In Go, you can declare a variable and define its type all in one statement. So that's just one cool little thing I wanted to show. Okay, so that's Go routines. The next thing is networking. Go comes built in with a very powerful net HTTP package, right? And what this lets you to do is build your own web server, right? So you don't need Express.js or any other library to make a web server. It all comes built in. Its features include HTTP and HTTPS, a static file server, request routing, HTML templating engine, and full HTTP2 support. I think Go is one of the first languages to support HTTP2 in its networking library. We're only going to look at two things today, the HTTP server and HTTP2 support. Okay? So, how do you create an HTTP server? The code's over here. It's pretty simple. You create a server mux, which is pretty much a router, and you specify the endpoints. So here we have two endpoints, the root endpoint and the greet endpoint, and we just listen for that router on port 8080. We have two handlers, the index handler, which just prints hello world, and we have the greet handler, which gets the name from the path parameter and says hello, or you didn't tell me your name. So we can try that. If we go here, go run server.go. So now our server is running. So you can do something like curl HTTP 8080 greet audience. Okay, hello audience. Or if you don't mention the name, you didn't tell me your name. Cool? Okay. And then HTTP2 push. Now Go has full support for HTTP2, and one of the features in HTTP2 is push. What that means is you send a request for the index.html file, but your web server can detect that, oh, if you want index.html file, index.html, you probably also want the JavaScript and the CSS file. So within the same request of index.html, it can send the JavaScript file and the CSS file. So the page loads much faster because instead of making 3 requests, it only has to make 1 that gets 3 files. All right. And the code to do that is really simple. You have your response writer that you had before. Sorry, didn't mention that. You have your response writer when you create a handler, and you simply check if the response writer can be cast to a pusher. A pusher is what's used to push files in the response, right? If it can be cast, if OK is true, that means that the client supports HTTP2. And if the client does support HTTP2, in addition to the index.html file, we're passing index.main.js. And you can do the same with a CSS file or any other file. So instead of making 3 requests, you're only making 1 request with receiving 3 files. To see the difference, you can visit the link over here. So, right now we're loading a picture with HTTP 1. I think there's 0 latency in this case. Let's just make sure. Yeah, this is HTTP 1 with 0 latency, right? And it takes a while to load. So there's an HTTP request for each tile of that image, right? Let's try the same thing with HTTP 2 and 0 latency. Instant, right? It makes a difference. And you can do that with Go. It has full support for HTTP 2. We can even try that with the maximum latency. So you try with HTTP 1 again. It's going to take even longer, which is awkward. Yeah, I'm not waiting that long. But HTTP 2, and yeah, pretty good. Okay. Next thing. Go also supports an encoding package which supports XML, JSON, and CSV. And it supports annotations the same way you might see them in, I think, C# and also JSON in Java or Jackson. So for example, I think there's an example here. Yeah. So, for example, we have a location type over here with latitude and longitude. We simply tag the fields with the name that we want in the JSON, and after that, simply we create a location variable, and to marshal it, we simply say JSON.marshal, and we pass a reference to the location, right? And this will print the JSON. To decode is simple, the same thing. You simply use the unmarshal function. You pass the bytes. Unfortunately, it only works with bytes, and you pass a reference to a location variable, and it will populate the data inside a location variable. Okay. So if you run this, struct to JSON, you get the JSON representation of that location structure that we had. And JSON to struct, we parse that JSON string over here back into that location structure earlier. Now you'll notice that Go has references and pointers. That sounds scary, but it's not, because Go has garbage collection. And not only that, Go has really cool garbage collection. Now normally, garbage collection is a problem for scalable applications because garbage collection involves stopping the entire program to run so that you can free memory. And this is called stop the world, or stopping the world. Stopping the world is not a good thing because it causes latency in requests. Go solves this problem because garbage collection in Go happens concurrently. So while your program is running, the Go garbage collector scans the memory, and there are only two stop the worlds per cycle, each one lasting less than a millisecond. I believe in Java it takes around 100 milliseconds or something, but up to a second actually. But in Go it's only two stop the worlds, less than 1 millisecond each. Okay. And lastly, we have Go tools. Go comes with a whole bunch of tools. The most famous one is Go Font. It's a formatting tool. What happens in most companies is you have these huge arguments about what code should look like. Should the curly bracket go up? Should it go down? Go has a Go Font package which specifies only one way of formatting Go code. So all the Go code looks exactly the same. And the way you use it is simply Go Font W to write to the file, and the path to your Go project, to your Go package, right? And this is a proverb in Go. Go Font style is nobody's favorite, but Go Font is everybody's favorite, right? So nobody likes Go Font's formatting, but everyone loves Go Font. Okay. Other Go tools, just a quick rundown. Go supports testing. It can even print the results of the test. GDB for debugging. Go Fix in case the Go version increases and you want to update your code. Go Run Race will detect race conditions, and you have Go Depth, which manages dependencies. Okay, so after all those features, what are the things that you need to be aware about before deciding to jump into Go, right? What are the language limitations? The main limitations that people say when they talk about Go is there are no generics, right? And so the drawback of this is that creating containers, for example, trees or sets, is really difficult because you have to just pretty much copy-paste code, which is exactly what people do. And this is an actual, I think, a tutorial where they're showing how to copy. You have a person, you want to create a set. So how do they do it? They copy the code from entry set and simply replace the word entry with person. This is how generics are currently done in Go because Go doesn't support generics. So not the most elegant solution. Okay, but Go 2 does promise generics, and this is what the syntax is going to look like. Just forget contract for now. So here we have a function called total. It takes a type T, and what we're doing is simply calculating the total. What is type T? Type T is addable, and addable is defined by a contract. Now, contract is a new feature that will also appear in C++, and it's also being planned for Go. What is a contract? A contract is not, even though it looks like a function, it isn't actually a function. It's a block that says that type T, the following lines should compile for type T. This code won't run. It's simply a block which the compiler will check to see if type T matches, if these two lines will compile using type T. Okay? So in the first example, we're calculating the total using 1, 2, and 3. So that what the compiler will do to make sure that these values are addable, it will go to the contract and see if this statement compiles. So can I do 1 plus equals 1? Yeah, I can. Can I do 1 times equal 2? Yeah, I can. So this value is addable. And all three of these values are addable, so this function is okay to call. But what about this function over here? Sorry, it's on the way. Total hello.world, right? So again, if we check in the addable contract, can I do hello plus equal world? Yeah, you can't add strings together. So that's why you need the second line, hello times equal to 2, which does not compile for strings. So these two values are not addable, so this line will not compile. And this is way better than generics in other languages like C++ or I think Rust. In C++, if you ever use generics, you get error messages that are really long and you don't even know where to begin. But in this case, the error messages that you can expect are simply that the variable hello does not meet the contract addable on line number 2, for example. So it's much easier to understand than generics. Okay? And this is how you can create generic containers in Go with this is what the syntax is going to look like. So Go does promise generics in version number 2. The next thing is error handling. You might have seen this earlier. Go's error handling is very repetitive. It does not have exceptions. Instead, it returns a value or an error, right? And every single time you have to check if the error is nil or not. And this can get really, really repetitive. Go 2 again does promise a way to fix this using the check and handle syntax. Every time a function returns an error, you can put the check word in front of it, and you can create a handle which specifies one way to handle errors. Okay? And that's pretty much it. How can you get started with Go? You can take the tour. Go offers a very cool tour over all the features of the language. We only covered a few of them. You can also build your own Go web app. This is a very good tutorial. Go has a web page, Effective Go, and which has pretty much all the best practices of Go. Check out Go open source projects, benchmark Go, see how it compares with the technology that you're using, and finally there's a video about what's planned for Go 2. And that's it. Any questions? Yeah.
My question is, what is the community response in terms of availability of free libraries like we have in lots for Python? So what is the current response for Go?
So there are a huge number of libraries in Go, and the good thing is they're all publicly available on GitHub. I couldn't mention it here, but if you look, the tool that we use to actually download packages is Go Get, and it works natively with GitHub, right? So most of the libraries in Go are all available in GitHub, and there are so many libraries. I wouldn't say, especially like Python has an advantage that it has a lot of libraries related to machine learning. I wouldn't say it has that many libraries about machine learning. It has mostly libraries related to networking, but there are a lot of them. So does that answer your question? Okay. Anyone else? Yeah.
Is there anything that in the version 2 are we introducing anything about dependency management in Go?
So the problem with dependency management, that's a good point actually, in Go is that what happened was that it would only get the library from the master branch. That's what you're talking about, right? That's actually already fixed. There's the tool, where is it? This tool called dep actually fixes that. So have you ever worked with Rust before? Okay, so in Rust you have like a toml file where you declare the dependencies, and you can even declare which version you want or which branch you want. So if you use the dep tool, that problem will be solved. That old problem isn't there anymore. Okay? Any other? Yes, at the back.
I remember there was a huge controversy about adding generics in Go. So
Yeah.
How did why did this decision change?
Well, there was a huge controversy. The thing is, you do need generics, as you mentioned, especially for containers, for sets and trees. Go does not natively support supply sets and trees, so you have to make them yourself. And so in the end, you do need generics. I'm not sure how to answer your question, but basically, in the end, generics did win out. And the authors of Go were never against generics. They were just trying to find a clean way of implementing it. They didn't want to repeat the mistake of C++, where you have generics, but you also had so much complexity. They wanted a simple way of implementing it. And that's why they went with contracts rather than the conventional generic syntax. Does that make sense? Okay. Sorry, you had a question?
Are there any frameworks for dependency injection?
Yeah, that's something I actually checked myself. I'm not sure actually. I just used constructor injection to be honest, but you can probably find this one. Anything else?
Do they support anything similar to annotation processing?
Yes, annotation processing. No. You're comparing it with Spring, right?
With Java in general, actually.
Yeah.
So things that it can remove some of the boilerplate code by processing annotations on compile time.
Yeah.
To auto-generate some code and all that.
Oh, okay, so first of all, compile time. Go is amazingly fast at compilation, so you don't need to worry about that. The second thing is, Java, the enterprise world is exactly what Java wants to avoid. It doesn't want to have it doesn't want to avoid dependency trees, but it doesn't want to have code that's difficult to follow. You know how it is with Java, where you have beans and they're coming in from different places, and you have whole configuration stuff. Go generally wants to try to avoid that. It wants to make the code that's simple and easy to read. It doesn't want to have complexity. That's why we had that graph from earlier, much earlier, right in the beginning. We want to have low complexity. But I'm pretty sure it does have dependency injection, but probably not with annotations. Annotations is kind of limited. But it does have a reflection package, so they might actually make something like that. Okay?
Yes.
Thanks, everyone.
Thank you.